Picture this. It's 1970, and you're standing at the starting line of a Georgia drag strip. The air is thick with tire smoke and nitro fumes. In the left lane sits a pristine Pontiac GTO, factory perfect with its single 4-barrel carburetor gleaming under the track lights. In the right lane there's another Pontiac, but something's different. Sticking through the hood like a chrome skyscraper is this bizarre contraption that looks like someone welded 2 carburetors on top of an aluminum tower. The crowd's confused. The announcer's confused. Even the other racers are shaking their heads. But when that Christmas tree lights up green, the weird Pontiac launches like it's been shot from a cannon, leaving the factory car in a cloud of tire smoke. The driver? A Georgia farmer named Arnie Beswick, who just outsmarted one of America's biggest automakers with a homemade intake manifold that Pontiac said couldn't work on their engines, 600 horsepower, from a naturally aspirated 428 cubic inch engine in 1970. Without a supercharger, without a turbo, without nitrous, just air, fuel, and one man's refusal to accept that Pontiac knew better than he did. This is the story of how Arnie, the farmer Beswick, took a rejected piece of Chevy technology, bolted it onto a Pontiac engine that wasn't supposed to accept it, and created a combination so devastating that it rewrote the rules of Pontiac drag racing forever. It's a tale of backyard engineering versus corporate expertise, of one racer's intuition against an entire engineering department, and how sometimes the best innovations come from the people who don't know what's impossible. To understand why Beswick's tunnel ram Pontiac was such a middle finger to conventional wisdom, we need to travel back to the muscle car wars of the late 1960s. General Motors was locked in a horsepower battle with Ford and Chrysler. Each division had its own approach to making power. Chevrolet was all about high-revving small blocks and big blocks that could spin to the moon. Chrysler had their legendary Hemis with massive combustion chambers and dual 4-barrel carburetors. Ford was pushing the limits with their 427 and 428 Cobra jets. And Pontiac? Pontiac was the rebel division of GM, the ones who created the GTO, and essentially invented the muscle car segment. But by 1970, Pontiac had a problem. Their engines made great street power, but on the drag strip, they were getting their doors blown off by tunnel ram-equipped Chevys and Mopars. See, Pontiac had invested everything in their single 4-barrel carburetor philosophy. Their engineers insisted that their engines, with their unique valve angles and port designs, worked best with a single carburetor and a conventional intake manifold. They'd developed the Ram air systems, the high-flow quadrajet carburetors, and various performance packages, but they steadfastly refused to develop tunnel ram intakes for their engines. A tunnel ram intake, for those unfamiliar, is essentially a tall dual-plane intake manifold with extremely long runners that positions 2 carburetors way up high, often sticking through the hood. The long runners create what's called a ram tuning effect. As air flows through these long tubes, it builds velocity and creates pressure waves that, at specific RPMs, actually force more air into the cylinders than atmospheric pressure alone would allow. It's like natural supercharging, but only at certain engine speeds. By 1970, tunnel rams were dominating superstock drag racing on Chevy and Chrysler engines, adding 75 to 100 horsepower over single 4-barrel setups. Pontiac's position was firm. Their engines didn't need tunnel rams. The 428 and 455 cubic inch engines made plenty of torque with single carburetors. The port angles weren't optimized for dual carburetor setups. The ram tuning effects wouldn't work properly with Pontiac's combustion chamber design. At least, that's what they told everyone. Enter Arnie Beswick. Now, Beswick wasn't your typical drag racer. He was an actual farmer from Macon, Georgia, who started racing in the late 1950s. By 1970, he'd already made a name for himself running Pontiacs, earning the nickname The Farmer, not just because of his day job, but because of his down-home approach to racing. While other racers showed up with trailers full of spare parts and teams of mechanics, Beswick would pull up in his pickup truck, unload his race car, and proceed to humiliate the competition. Beswick had been running Pontiac 428s in super stock, but he was tired of giving up 100 horsepower to the tunnel ram, Chevys, and Mopars. He'd approached Pontiac about developing a tunnel ram intake for the 428, but they weren't interested. Their engineers maintained it wouldn't work properly. So Beswick decided to prove them wrong. Working in his shop in Georgia, Beswick started with an Edelbrock tunnel ram intake manifold designed for a big block Chevy. Now, here's where it gets interesting. Pontiac and Chevy, big blocks, might both be GM products, but they're completely different animals. The bore spacing is different, the port angles are different, the deck heights are different. You can't just bolt a Chevy intake onto a Pontiac engine. It's like trying to put helicopter blades on an airplane, but Beswick wasn't trying to make it bolt on. He was going to make it work. Using a combination of welding, grinding, and pure Georgian stubbornness, he modified the Edelbrock tunnel ram to fit the Pontiac 428. This meant re-angling the runners to match Pontiac's port angles, creating custom adapter plates, and essentially re-engineering the entire intake manifold. The fabrication work alone took weeks. Every runner had to be perfectly matched to its corresponding port. The plenum volume had to be recalculated for the Pontiac's displacement and cam timing. The carburetor spacing had to be adjusted to properly feed all 8 cylinders. On top of this aluminum monstrosity, Beswick mounted 2 Holley 660 CFM carburetors. Now, the Pontiac 428 typically came with a single 750 CFM quadrajet, so 2 660s meant he was flowing 1,320 CFM total. That's 76% more airflow capacity. But raw airflow isn't everything. The carburetors had to be synchronized perfectly, jetted correctly for the Pontiac's fuel requirements, and the accelerator pump circuits had to be calibrated to prevent bog on launch. The first time Beswick fired up his tunnel ram 428, it sounded different. Pontiac engines have a distinctive exhaust note, kind of a mellow rumble compared to the choppy idle of a Chevy or the angry bark of a Mopar. But with the tunnel ram, Beswick's 428 had a sharp, crisp sound. It revved quicker, pulled harder at high RPM, and made sounds no Pontiac had made before. But the real moment of truth came at the dyno. Beswick's standard 428 with a single 4-barrel made about 500 horsepower on a good day, good power, but not exceptional by superstock standards. When they strapped the tunnel ram 428 to the dyno and made the first pull, nobody believed the numbers: 600 horsepower, 620 foot-pounds of torque. The dyno operator thought his machine was broken. They recalibrated and ran it again. 602 horsepower. Here's what was actually happening inside that engine. The tunnel ram's long runners were creating a ram tuning effect that peaked at exactly 6,500 RPM, right where Beswick's cam timing and valve events were optimized. As the intake valves opened, the pressure waves traveling down those long runners would arrive at exactly the right moment, cramming extra air into the cylinders. It was like having a tiny supercharger that only worked at specific RPMs, but didn't cost any horsepower to drive. The Pontiac engineers had been partially right. The ram tuning effect didn't work well at low RPMs. Below 3,500 RPM, the tunnel ram 428 was actually slower than a conventional intake. The long runners that created high RPM power also created lag and poor throttle response at low speeds. But Beswick wasn't building a street car. He was building a drag race weapon, and in superstock, you launch at high RPM and keep it there for the entire quarter mile. But wait, there's more. The tunnel ram setup had another advantage that even Beswick didn't fully anticipate. The height of the carburetors, sitting up above the engine, meant they were getting cool, dense air instead of the hot air that typically surrounds an engine compartment. Cooler air is denser air, and denser air means more oxygen molecules per cubic foot, which means more power. The tunnel ram was essentially getting a ram air effect even when the car was sitting still. Beswick's first race with the Tunnel Ram 428 was at the 1970 NHRA Southern Nationals in Commerce, Georgia. He rolled into the pits with his tunnel ram sticking through the hood, and the other racers literally laughed. Pontiac guys thought he'd ruined a perfectly good engine. Chevy guys figured a farmer from Georgia didn't know how to properly set up a tunnel ram. The Mopar crowd just shook their heads. The laughter stopped during first-round eliminations. Beswick's tunnel ram Pontiac ran a 10.92 at 127 miles per hour. In 1970, super stock trim, those were professional-level numbers. His 60-foot time was 1.38 seconds, indicating the tunnel ram wasn't hurting his launch despite the low-speed lag. By the time he reached the 8th mile mark, the tunnel ram was in its sweet spot, and the Pontiac was pulling like a freight train. But here's where Beswick's genius really showed. He didn't just bolt on a tunnel ram and call it done. He'd spent months developing a complete package. The cam timing was specifically ground to work with the tunnel ram's ram tuning effect. The valve springs were selected to handle the higher RPMs the tunnel ram enabled. The ignition curve was tailored to the new airflow characteristics. Even the exhaust headers were modified to work with the increased airflow. The transmission was a close-ratio Muncie M22 Rock Crusher 4-speed, but Beswick had modified the gear ratios to keep the engine in the tunnel ram's power band. First gear was actually taller than stock to prevent wheel spin with all that torque. Second gear was closer to first to minimize RPM drop. Third and fourth were spaced to keep the engine between 5,500 and 7,000 RPM, right where the tunnel ram made its best power. The rear end ran 4.88 gears, which seems incredibly steep by today's standards, but remember, Beswick was turning 7,000 RPM through the traps. Those gears kept the engine in the tunnel ram's sweet spot for the entire run. The clutch was a sintered iron unit from Schiefer, capable of handling the tunnel ram's brutal torque without slipping. Even the chassis setup was optimized for the tunnel ram's power delivery. Beswick ran a ladder bar rear suspension with adjustable shocks. The front shocks were 90-10 drag units that extended easily but resisted compression, helping weight transfer on launch. The rear shocks were 50-50 units that controlled the hit without being too stiff. The front springs were cut to lower the nose and improve weight transfer. The rear springs were actually station wagon units, stiffer to handle the tunnel ram's torque. By the end of 1970, Beswick's tunnel ram 428 was virtually unbeatable in superstock. He won the Southern Nationals, the Gator Nationals, and placed in the top 3 at the NHRA Nationals. Other Pontiac racers started approaching him about building tunnel ram setups for their engines. Suddenly, the modification that Pontiac said wouldn't work was the hot ticket in Pontiac drag racing. The impact on Pontiac's engineering department was immediate and embarrassing. Here was a farmer from Georgia proving their engineers wrong in the most public way possible. At every race, Beswick's tunnel ram Pontiac was beating factory-backed cars with conventional intakes. The automotive press picked up the story. Hot Rod magazine did a feature on Beswick's setup. Carcraft published dyno tests showing the 100-horsepower advantage. Pontiac's response was predictable. They claimed Beswick's setup only worked for drag racing, not street driving. They were right, of course, but that wasn't the point. The tunnel ram proved that Pontiac engines could make just as much power as Chevys and Mopars if given the right induction system. It showed that Pontiac's refusal to develop tunnel rams wasn't based on engineering limitations, but on corporate stubbornness. By 1971, other manufacturers started producing tunnel ram intakes specifically for Pontiac engines. Edelbrock, Offenhauser, and Wyand all introduced Pontiac tunnel rams, all based on the principles Beswick had proven. The cat was out of the bag. Within 2 years, tunnel ram Pontiacs were common in superstock and pro stock racing. But let's dive deeper into the technical aspects of why Beswick's tunnel ram worked so well. The Pontiac 428 had unique characteristics that actually made it ideal for tunnel ram induction once you solved the fabrication challenges. The engine's 4.12-inch bore and 3.75-inch stroke created a bore-to-stroke ratio of 1.099, making it slightly over square. This meant it could rev higher than a typical big block while still making massive torque. The Pontiac's valve arrangement was also unique. Unlike Chevy and Ford big blocks that used inline valves, Pontiac used canted valves, angled at 14 degrees from vertical. This created better airflow at high lift, but required specifically shaped ports. Beswick's tunnel ram modifications accounted for this, with custom fabricated runners that matched the angle of the ports perfectly. The combustion chambers on the 428 were wedge-shaped with a volume of 72 cc in Beswick's high compression setup. This created a compression ratio of 11.5.1 with the forged pistons he was running. High compression was crucial for the tunnel ram because the long runners could cause some fuel to drop out of suspension at low speeds. The high compression helped burn this fuel more completely. The camshaft Beswick chose was a solid lifter unit with 0.520-inch lift and 308 degrees of advertised duration. The lobe separation angle was 108 degrees, tighter than stock, to increase overlap. This overlap was key to the tunnel ram's effectiveness. During the overlap period when both valves are slightly open, the ram tuning effect could actually create a scavenging effect, using the incoming air to help pull exhaust gases out. The ignition system was another crucial component. Beswick ran a dual-point distributor with a rev limiter set at 7,200 RPM. The advance curve was locked out at 38 degrees total timing, all in by 2,800 RPM. This aggressive timing took advantage of the tunnel ram's improved air-fuel mixing. The dual points ensured consistent spark at high RPM when single-point systems would start to float. The fuel system required massive modifications. A mechanical fuel pump couldn't keep up with two 660 CFM carburetors at full throttle, so Beswick installed an electric Carter strip pump flowing 140 gallons per hour. The fuel line was upgraded to -8 AN braided stainless, and he ran a fuel pressure regulator set at 7.5 psi. Too much pressure would overpower the needle and seats. Too little would cause lean conditions at high RPM. The carburetors themselves were heavily modified Holley 4150 series units. The primary jets were 78s in front and 84s in the rear. The secondary jets were 86s all around. The power valves were blocked off and replaced with fixed jets because the tunnel ram's plenum pressure played havoc with power valve operation. The accelerator pumps were upgraded to 50 cc units with hollow shooters to prevent bog-on throttle application. Air cleaners were another challenge. The tunnel ram positioned the carburetors so high that conventional air cleaners wouldn't fit under any hood. Beswick ran velocity stacks with foam elements, creating a ram air effect when the car was moving. At 120 miles per hour, this added another 2 to 3% horsepower from the increased air pressure. The exhaust system was equally important. Beswick ran Hooker Super Competition headers with 2-inch primaries and 3.5-inch collectors. The primary tubes were 32 inches long, tuned to create a scavenging effect at 6,500 RPM, the same frequency as the tunnel ram's resonance. The collectors fed into 3-inch exhaust pipes with Flowmaster mufflers, though mufflers is generous. They were basically straight-through units that did little to quiet the exhaust note. The cooling system needed upgrades to handle the extra heat from 600 horsepower. Beswick installed a Griffin aluminum radiator with dual electric fans. The water pump was an Edelbrock high-flow unit spinning 20% faster than stock via an overdrive pulley. He ran a 160-degree thermostat and water wetter additive to improve heat transfer. Even with all this, the tunnel ram 428 ran hot, typically seeing 210-220 degrees after a quarter-mile pass. Beswick's driving technique had to adapt to the tunnel ram's characteristics. Launch RPM was critical. Too low and the engine would bog. Too high, and he'd blow the tires off. He found the sweet spot at 4,800 RPM, slipping the clutch slightly to keep the engine above 4,000 where the tunnel ram started working. Shift points were at 6,800 RPM, just past the power peak but before valve float. The psychological warfare aspect of Beswick's tunnel ram shouldn't be understated. When you pulled up next to a car with that aluminum tower sticking through the hood, it was intimidating. The sound was different too. At idle, the tunnel ram created a hollow, echoing sound from the long runners. When Beswick revved it, the intake noise was almost as loud as the exhaust. It sounded like the engine was trying to inhale the entire atmosphere. Other racers started calling Beswick's car the farmer's folly early on, mocking the ungainly appearance of the tunnel ram. But as he kept winning, the name evolved to the Georgian Guillotine because it cut down everything in its path. The tunnel ram became Beswick's signature, as recognizable as any paint scheme or sponsor decal. The financial impact of Beswick's innovation was significant. Before his tunnel ram success, Beswick was spending about $15,000 a year on his racing program, funded entirely by his farming income. After proving the tunnel ram's effectiveness, he started selling conversion kits to other racers. At $20,500 per kit, including the modified intake, carburetors, and detailed setup instructions, he sold over 50 units in 1971 alone. That's $125,000 in revenue, or about $850,000 in today's money. Pontiac's eventual response was telling. In 1972, they quietly released a technical bulletin to their dealers acknowledging that tunnel ram intakes could be effective on 428 and 455 engines in certain racing applications. They never officially produced a tunnel ram, but they stopped discouraging their use. Some historians argue that Pontiac was already planning to explore tunnel rams before Beswick's success, but internal documents suggest otherwise. The engineering department was genuinely surprised by the effectiveness of his setup. The tunnel ram's influence extended beyond just Pontiac racing. It proved that sometimes innovation comes from outside corporate engineering departments. It showed that racers, the people actually using the products, often understand what works better than the engineers designing them. This philosophy would later influence the entire aftermarket industry, with companies like Holley, Edelbrock, and others hiring successful racers as consultants. Beswick continued racing his tunnel ram Pontiacs through the mid-1970s, adapting the setup to the 455 Super Duty when it became available. He eventually moved into pro stock where tunnel rams were standard equipment, but he always credited that first 428 tunnel ram as the innovation that made his career. He retired from professional racing in 1978 but continued building engines for other racers well into the 1980s. The specific car that started it all, Beswick's 1970 Pontiac with the first tunnel ram 428, survived and is now in a private collection in Florida. It was restored in 2015 to exactly the condition it was in during the 1970 season, including the hand-fabricated tunnel ram intake. At the 2016 Muscle Car and Corvette Nationals, it sold at auction for $287,000, with the tunnel ram setup specifically cited as the reason for the high price. The technical legacy of Beswick's tunnel ram extends to modern performance. Today's composite plastic intake manifolds with tuned runners owe their existence to pioneers like Beswick, who proved that runner length and plenum volume were critical to making power. Modern cars like the Dodge Hellcat and Shelby GT500 use variable runner length intakes that change their geometry based on RPM, essentially giving you a tunnel ram effect at high RPM and conventional intake characteristics at low RPM. Even Pontiac, before their demise in 2010, eventually acknowledged Beswick's contribution. In 2004, at the Pontiac Nationals, they presented him with a Special Achievement Award for advancing Pontiac performance technology through independent innovation. It only took them 34 years to admit he was right. The story of Arnie Beswick and his tunnel ram 428 is more than just a tale of horsepower and quarter-mile times. It's about challenging authority, thinking outside the corporate box, and proving that sometimes the best engineers are the ones with grease under their fingernails rather than degrees on their walls. It's about how one man with a welding torch and a refusal to accept "that won't work" changed an entire segment of motorsports. Beswick proved that Pontiac engines weren't limited by their design, but by their designer's imagination. He showed that a farmer from Georgia could out-engineer a multi-billion-dollar corporation. He demonstrated that in racing, as in life, the person willing to try what others say is impossible is often the one who ends up in the winner's circle. The tunnel ram revolution Beswick started influenced not just Pontiac racing, but the entire muscle car performance industry. It established the principle that factory engineers don't always know best, that racers are the ultimate R&D department, and that sometimes the weirdest-looking solution is the most effective one. Today, when you see a modern pro stock car with its massive scoop and tunnel ram intake, remember it all started with a Georgia farmer who refused to accept that his Pontiac couldn't run with the big dogs. When you see a street car with a hood scoop, even if it's just decorative, you're looking at the descendant of Beswick's breakthrough. Every aftermarket intake manifold, every cold air intake system, every ram air setup owes something to the principle Beswick proved. More air equals more power, and sometimes you have to build it yourself to get it right. The tunnel ram 428 remains one of the most significant innovations in Pontiac performance history, not because Pontiac built it, but because they didn't. It stands as testament to the ingenuity of American hot rodders, the value of questioning authority, and the power of proving everyone wrong at 127 miles per hour. Beswick passed away in 2019 at the age of 84, but his legacy lives on in every Pontiac that runs a non-factory performance part, every racer who questions conventional wisdom, and every engineer who learns that sometimes the best innovations come from the people who actually use the products. He didn't just build a faster Pontiac. He built a philosophy that says innovation belongs to anyone willing to pick up a wrench and prove the experts wrong. So the next time someone tells you something won't work, remember Arnie Beswick and his weird tunnel ram that wasn't supposed to make power on a Pontiac engine. Remember that sometimes the best engineering comes from farmers, not factories. And remember that 600 horsepower from a naturally aspirated 428 was impossible until one man in Georgia decided it wasn't. What's the wildest engine modification you've ever seen actually work? Drop a comment below and let me know. If you enjoyed this deep dive into Pontiac history and grassroots innovation, hit that subscribe button for more stories about the rebels who refuse to accept that the factory knows best. Thanks for watching, and remember, sometimes the weirdest looking solution is the one that leaves everyone else in the dust.